Assalamualaikum. This is chemistry 11th, and our today's lecture is about these D and F blocks of the periodic table. Dear students, I have already told you that the modern periodic table has been divided into four blocks. We have got S block, we have got this P block, we have got D block, and then we have got F block. So this type of classification has been, or this division has been made on the basis of that has been made on the nature or the type of orbital in which the lost electron is filled. Now as far as this classification of or sorry this division of the periodic table is concerned, now as far as now I would like to read this D block. Now the elements in this D block, you can see here, this is the D block of D block group of the this periodic table. Now the elements in which the lost electrons are filled in D subshell are the lost but one penultimate energy level. That means one the electrons are filled in the lost, the electrons are filled in D subshell of the outermost but penultimate shell are called as D block elements. Since the D subshell has got a capacity, or it has got a capacity of holding 10 electrons, or it can accommodate a maximum of 10 electrons in its 5 orbitals, as D subshell consists of 5 orbitals. So this block of the periodic table, it consists of 10 groups, starting from this group 3 to group 12. This you can see here: 1 2 3 4 5 6 7 8 9 and 10. So there are 10 groups of this block of the periodic table. Now their outermost S subshell, that is NS, it is complete, or it can have one or two electrons. Now while filling takes place in the penultimate subshell, that is D subshell, that is n minus 1 D. This is I am telling you about this D block of the periodic table. Now their general outer electronic configuration is, you can see here, it is n minus 1, that is penultimate shell 1 to D, ns2, that is ns, this outer shell, this S subshell is outer S subshell, it is complete, but inner, since it is inner, the filling takes place in inner n-1 D subshell. So this is their general outer electronic configuration. Now these D block elements are also called as transitional. They are also called as transitional elements because they act as a transition, or they act as a transition between these between S and P blocks of the periodic table, and their properties are in between, or midway between S and P block elements of the periodic table. Now the elements of group this S and P block, they are also called as representative elements, because in case of these S and P block elements, we see there is normal filling of electrons. Now as far as this D, since we are discussing in our today's lecture this D block, now this as far as this D block is concerned, there are four transitional series. The first transitional series, it starts from scandium. You can see here with atomic number 21 to 30 up to zinc. It starts from scandium to zinc, formed by filling of electrons in the 3D subshell. So here you can see the filling of electrons takes place in 3D subshell in the fourth period. You see, this is the fourth period, but the filling takes place in the 3D subshell. Now the second transitional series, you can see it starts from yttrium to cadmium. Yttrium has got atomic number of 39, cadmium has got an atomic number of 48. So there are 10 elements in this second transitional series, and this second transitional series, as you know, it is obtained, or it is formed by filling of electrons in the 4D subshell, and in the 4D subshell in the fifth period of the periodic table. This is the fifth shell, and the filling takes place in 4D subshell in the fifth period. Then we have got the third transitional series, which starts from lanthanum hafnium. Lanthanum has got atomic number of 57, and hafnium has got atomic number of 72. So from lanthanum hafnium to mercury with atomic number 80. Atomic number of has got mercury has got atomic number of 80. So again we see there is a group of 10 elements in this series, in the third transitional series, and this is obtained by filling of electrons in the this is obtained by filling of electrons in the 5D subshell, 5D subshell, and in the sixth period. Then we have got the fourth transitional series, which starts from this actinium. It has got atomic number of this 89, and this is this transitional series, it is incomplete transitional series, the fourth transitional series, which is formed by filling of electrons in the 6D subshell in the seventh period of the periodic table. Now as far as the characteristics of this D block elements are concerned, these are all metals which have got high melting and boiling points. Number one. Number second characteristic is that most of the D block elements form colored compounds. They form colored compounds, and these also form complex compounds. Now then we have got another feature of this D block is that the elements of these elements, they show variable oxidation states depending upon the number of depending upon the number of D orbitals which are involved in this in chemical bonding or in hybridization process. Then we have got this another feature of these D block elements is that the compounds of these D block elements, they are paramagnetic in nature. They have got that means they have got unpaired electrons. Then another feature of these D block elements is that they have got a tendency to form alloys with other metals. Similarly, one more characteristics of these D block elements is that the large number of these D block elements, like we have got iron, cobalt, nickel, manganese, chromium, platinum, vanadium, etc., they act as catalysts. Now, this is about the D block of this periodic table. Then we have got one more block, that is the F block. F block of this periodic table. As far as this block is concerned, in these elements, the filling of lost electrons, it takes place in n-2 F subshell of the outermost shell. That means anti-penultimate this shell. Now their outer NS subshell, the outer NS subshell that is complete with 2 electrons, but n-1 D subshell, it may contain it may contain 0, or it may contain 1, 2, 3, 4 up to 10 electrons. Then as far as their general outer electronic configuration is concerned, you can see it is n-1 F1 to 14. This is the this is anti-penultimate shell. Then you have got this n-1 D1 to 10. This is the penultimate shell. This is the outer NS2 shell, that is complete. Now this is their general outer electronic configuration. Now as far as this block is concerned, these F block elements, they are also called as these are also called as inner transitional elements. And we have got these two series of these inner transitional elements comprising of 14 elements each. Now the first transitional series of 14 elements which starts from this cerium to lutetium. Now this is formed by filling of electrons in 4f subshell. That means n-2 F in this is in, you can see here, it is in the sixth period. This is the sixth period. It starts from lanthanum with atomic number 57. So it is formed by filling of electrons in 4f subshell in the sixth period from cerium to this is lutetium, and these are also called as lanthanides, as they follow the element lanthanum, which is a D block element with atomic number 57. Then we have got this another series or second series of these F block elements that consists of 14 elements. This is formed by filling of electrons in the 5f subshell. That means n-2 F in the seventh period. This is the seventh period, and it starts from actinium with atomic number 89. Now these are called as actinides because they follow this element. This is actinium. I have told you this atomic number is 89, and it is a d block element, this actinium. Now it starts this second transition, this inner transitional series or second f block series. It starts from this thorium with atomic number 90 to lawrencium with atomic number 103. Now since these as these we have got these two series, that is lanthanides and actinides, there is no place at their proper, at their original position. So they have been put separately at the bottom of this long form of periodic table. You can see here the two series, lanthanides and actinides. Now as far as the characteristics of these F block elements are concerned, the F block elements are, these are heavy metals, and they have got a high melting and boiling points. And number third characteristics of these F block elements is that just like D block elements, these F block elements they also form these complex salts. Then we have got this another feature of this F block is that these the elements of this F block, they show a variable oxidation state in their compounds, although the +3 oxidation state, that is the common in these F block elements. Then we have got another feature, these of these block elements, that the compounds of these elements, they are generally colored. So these are the various features of these F block elements, and I have also told you about these D block elements. So this is for today, and in our this is for today, and since our time is, we have got a stipulated time, so this is for today. Thank you very much.